Okay, so this is going to be a takeoff on all of the stuff that we learned so far. And it's going to be a little bit of a challenge for you because now you have to know this formula, y equals to a x minus p squared plus q. You have to know it cold. And you have to remember, what does the a value tell you? What does the p value tell you? What does the q value tell you in order to solve the next set of questions? You have to know this so cold, it's scary. So go back and watch some podcasts again to make sure that you know it cold. But here we go. The point, you've got a point, 3,9 is on this graph. Well, how can you prove that? Well, look, isn't that an x coordinate? Isn't that the y coordinate? Substitute it in. 3 squared, guess what? That equals to 9. So there's your point, 3, 9. That's simple. Now, the whole idea behind this is we're going to do some stuff to this, okay? Describe what happens to this point when we do something to this. Okay, so we're going to do some transformations. So in other words, we're going to shift it up, down, left, right. We're going to widen it, narrow it, and so on and so forth. The whole idea then is, tell me, what is the new point going to look like once we've done some transformations to it? And then guess what? Based on this formula right here, write me the new function. Okay, so sounds like a mouthful, right? But boy, I tell you, there's some really cool stuff coming up right away. Okay, so let's look. In 1, it says you're going to horizontally translate something 6 units left. Okay, what does 6 units left mean? I don't know. Let's read the rest of the question. Followed by a vertical translation, which means moving up or down 3 units down. Okay, so 3 units down. So let's go interpret this again. A horizontal translation means moving left or right, but I'm going left, so I'm going that way, 6 units. So whenever I go left, that means I'm going negative. Followed by a vertical translation of 3 units down. 3 units down means I'm going this way, 3 units. Now, if you really interpret this, remember, left and right horizontal means you're making an x translation. You're moving along the x-axis. Up and down, guess what? Yep, you're going along the y-axis. So let's look at that point. The point was originally 3, 9. So if I'm going x-axis now, if I'm going left, I am going negative to the x. So I'm going negative 6. In terms of the y-axis, I'm going down, so I'm going down minus 3. So hey, I could just do that right here. My new point is going to be minus 3, just add them, 6. My new point is minus 3, 6. Now, you're probably saying, well, wait a second. How can that possibly be? Well, simple. If you're going to move 1 point 6 units left, followed by 3 units down, you're moving the entire graph. Think about this. The original graph, f of x equals x squared, goes right through the origin. You're moving everything 6 left, 1, 2, 3, 4, 5, 6, and 3 down, 1, 2, 3, even the vertex. The vertex, if you think about it, is now minus 6, minus 3. So that's going to help you give the equation. See what I mean? There's your new vertex. So think about this. Did we make it bigger, wider, or narrower, or anything like that? Did we flip it? No. So it's still x squared. So your new graph is still going to be x squared. So your a value is exactly the same. It's 1. But we now have a new vertex of x minus a minus 6 squared minus 3. So this now becomes y equals to x plus 6, don't forget the squared, minus 3. There's your new equation. Isn't that cool? A lot of talking, a lot of moving, but ho, 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 some real neat stuff coming up here. Now, let's look at number 2. Okay, a little bit more complicated now, right? Okay, so here we go. Read through it. Notice how I'm reading through just about every question twice just to make sure I understand it. So it says a stretch vertically by a half and a reflection in the x-axis. Okay, wait a second. I'm stretching vertically. I'm stretching vertically, so I'm affecting the y coordinate, aren't I? and a reflection over the x-axis. So if you think about it, it's over the x-axis means if it was here, it's now here because there's the x-axis. So in other words, all I'm doing is making a parabola that was up, I'm making it down now. Notice I didn't shift it left or right. I'm just stretching it and reflecting it. How is this going to affect our original coordinates? Our original coordinates, which were 3, 9, right here. How is this going to affect this? Well, let's go. We're doing vertically. So remember, 3, 9 means vertically. Vertically, that means this guy here, right? And in a reflection, also, look, the x coordinates are the same. It's the y coordinate that gets flipped. So in fact, we're multiplying this 9 by a half, which makes this 9 over 2, and we're flipping it over the x coordinate, affecting the y coordinate here, making this a negative. So our new point will actually be 3, negative 9 over 2. Oh my goodness, that looks kind of interesting, doesn't it? All right, so let's give the new formula for this. Well, the new formula is still based on the general, or I should say the vertex formula that we're used to, y equals to a, x minus p squared plus q. Remember, our original was y equals to x squared. Now, here's the tough part. P here, we didn't move left or right. So P is a 0. The Q here, we didn't move up or down. So that's a 0. So we're still playing with y equals to a x squared, right? The only thing we played with was this guy. Remember, it became stretched vertically by a half and reflected, which means this is now y equals to stretched vertically by a half and reflected. There's your new formula. And if you want to try this, if you want to try the original point, right? The original x, which was 3, and the original point, which was 3, 9, right? Okay, try 3, 9 in your new formula. Okay, so 3, 9, y equals to minus a half, x is 3 squared, right? Which becomes 9. There's minus a half times 9. Half of minus 9 is minus 9 over 2. And look at that. Look how that coordinate is the same one we determined, oops, way back here. Look at that. So you can either determine it by figuring out the formula first and substituting in the original value and get your new y, or you can just do it logically and do it here. All right, here we go. Now, let's go, and I'm going to clean this up, so I'm going to put a pause for a second. I'm going to clean this up, and then we'll be back for number 3. All right, so take a look at the last one. This is really, really interesting. Read what it says. It says a multiplication of the y values by a factor of 4, and then a vertical translation of 3 units down. Okay, so let's interpret this. We're multiplying the y values by a factor of 4. Wait a second. That means our original y has now got a factor of 4 in front of it, because it's going to take all our old values, which are just plain old x squared, and we're going to multiply them all by 4. Guess what we just said? We just gave you the a value. A equals to 4. And then a vertical translation of 3 units down. So we're going down 3. So guess what? That's got to be, from our PQ value, that's going to be our Q value. It has to be. So look how fast I can actually write the formula for this. There's our factor of 4 down 3. Isn't that cool? All based on this original formula of ax minus p squared plus q. There's our vertical, there's our horizontal, there's our movement of vertical. This is our stretch factor right here, okay? So we can either look at the original question, original value of 3, 9, which was our original value, and just apply everything to this. Well, okay, let's try that. Okay, let's take this 9. Okay, we're going to multiply this by a factor of 4, and then we're going to translate it 3 down. Okay, so 9 times a factor of 4, which is 36, translated 3 down, which means down, take away 3, you should get a value of 33. Let's see if we get that from this formula that we constructed, okay? Let's see if we get that. Here we go. This is y equals to 4x squared. X was originally 3, okay? 3 squared minus 3. 3 squared is 9. Minus 3, that's 36. Minus 3, look at that, 33. And this formula, in fact, does work. All right, so this is a really nice way of looking at your y equals to ax minus p squared plus q formula and really knowing all the nitty-gritty stuff that goes along with it.